So, just as a warm-up here, I'll be doing mental maths, and then I'll be doing the real thing. 47 times 53 is 2,491. 96 times 104 is 9,984. 25 times 84 is 2,100. 15% of 240 is 36. 68 times 72 is 4,896. 1,000 take 687 is 313. 125 times 88 is 11,000. 35 squared is 1,225. 89 times 91 is 8,099. 498 plus 302 is 800. 76 times 84 is 6,384. 12.5% of 640 is 80. 57 times 63 is 3,591. 95 squared is 9,025. Okay. 72 times 11 is 792. 4,003 take 2,997 is 1,006. 64 times 75 is 4,800. 18 times 5 is 90. 102 times 98 is 9,996. 3/8 of 240 is 90. 34 times 46 is 1,564. 1,250 plus 750 is 2,000. 24 times 25 is 600. 4% of 350 is 14. 112 times 128 is 14,336. 65 squared is 4,225. 999 divided by 3 is 333. 88 times 125 is 11,000. 50% of 864 is 432. 73 times 77 is 5,621. 5,006 take 1,994 is 3,012. 144 times 25 is 3,600. 37 times 3 is 111. 20% of 85 is 17. 48 times 52 is 2,496. 1001 times 7 is 7,007. 99 times 99 is 9,801. 75% of 96 is 72. 132 times 50 is 6,600. 40 squared minus 6 squared is 1,564. 86 times 94 is 8,084. 3,300 divided by 12 is 275. 105 squared is 11,025. 3/4 of 128 is 96. 29 times 31 is 899. 998 plus 502 is 1,500. 16 times 125 is strange. What is that? 2,000? No. Yes, that's right, 2,000. 8% of 250 is 20. 54 times 56 is 3,024. 1,440 divided by 12 is 120. 15% of 60 is 9. 62 times 58 is 3,596. 2,500 take 1,275 is 1,225. 45 times 11 is 495. 7/8 of 160 is 140. 115 squared is 13,225. 90 times 110 is 9,900. 360 divided by 24 is 15. 19 times 21 is 399. 12.5% of 80 is 10. 82 times 78 is 6,396. 4,200 divided by 25 is 168. 27 times 33 is 891. 999 times 2 is 1,998. 35 times 25 is 875. 2/5 of 350 is what? 140. 101 times 99 is 9,999. 600 take 217 is 383. 55 squared is 3,025. 250 times 44 is 11,000. 1/8 of 1,000 is 125. 43 times 47 is 2021. 7,200 divided by 25 is 288. 13 times 17 is 221. 30% of 270 is 81. 125 times 32 is 4,000. 1,012 take 988 is 24. 85 times 95 is 8,075. 3/5 of 450 is 270. 44 times 46 is 2,024. 10,000 take 3,791 is 6,209. 75 times 24 is 1,800. 6.25% of 320 is 20. 28 times 32 is 896. 900 divided by 36 is 25. 103 times 97 is 9,991. 7 times 143 is 1,001. 1/4 of 1,200 is 300. 59 times 61 is 3,599. 2,750 plus 2,250 is 5,000. 96 times 25 is 2,400. 40% of 175 is 70. 66 times 74 is 4,884. Yes. 81 times 11 is 891. 17 times 19 is 323. 500 divided by 8 is 62.5. 104 squared is 10,816. 37 times 27 is 37 times 27. 999. 111 times 9 is 999. 25% of 1,480 is 370. Okay, next we can do chapter 12. Which is differentiation. All right. For y equals x squared, state the gradient of the curve at the point where x equals 5. So dy by dx equals 2x, sub in x equals 5, and we get 10. So 10 is the gradient of y equals x squared at the point where x equals 5. A curve has gradient function dy by dx equals 3x squared take 12. What is the gradient of the curve when x equals 1? Simply substitute 1 and we get negative 9. So negative 9 is the gradient of the curve which has the gradient function dy by dx equals 3x squared take 12 when x is equal to 1. A curve has the gradient function dy by dx equals 4x take 7. Find the value of x when the gradient of the curve is 5. Okay, solve 5 equals 4x minus 7. Okay, so x is equal to 3. So when x is 3, the curve with the gradient function dy by dx equals 4x take 7 has a gradient of 5. For y equals x cubed, find the gradient to the curve at the point negative 2, negative 8. So dy by dx equals 3x squared. Then sub in negative 2 for x. The result is 12. And yes, that makes physical sense. So 12 is the gradient of the curve y equals x cubed at the point negative 2, negative 8. Hello. For the curve y equals x squared, find in its simplest form the gradient of the chord joining x equals 2 and x equals 2 plus h. Alright, at x equals 2, the point on the curve will be 2, 4. And at x equals 2 plus h, the point on the curve will be 4 plus 4h plus h squared. And then what we do is we do the change in y over the change in x. Now, 4 plus 4h plus h squared minus 4 is 4h plus h squared, and then that has to be divided by h. So we get 4 plus h. So 4 plus h is the simplest form of the gradient of the chord joining x equals 2 and x equals 2 plus h on the curve y equals x squared. Okay, section 2 is differentiation from first principles. Expand 3 at h all squared, take 9 over h, giving your answer in terms of h. So for the numerator, we expand 3 at h all squared, so we get 9 at 6h at h squared, take 9, which becomes 6h at h squared, and then 6h at h squared over h is 6 at h. So 6 plus h is the simplest form of 3 at h all squared. 3 at h all squared, take 9 over h. Hello. Find the limit as h approaches 0 of x at h all cubed, take x cubed over h. So this should reduce to 3x squared. But if we actually go through the process and we cube x at h, well, if you cube x at h, you get x cubed plus 3x squared h plus 3xh squared plus h cubed, and then we have to take away x cubed. So on the top we have 3x squared h plus 3xh squared plus h cubed, and then we have to divide everything by h, and thus we have 3x squared plus 3xh squared, no, plus 3xh plus h squared. Okay, and then as h approaches 0, those latter two terms become irrelevant, and so we end up with 3x squared, which is the intended result. Use first principles to find f prime of x when f of x equals 5x squared. So, as before, the general form is the limit as h approaches 0 of f of x at h, take f of x all over h. And in this case, we already know that this is going to reduce to 10x. So there's no need to go through the laborious process of that. But you can if you really want to. For f of x equals 1 over x, find the limit as h approaches 0 of f of x at h, take f of x all over h. Okay, so differentiating the reciprocal function from first principles. Again, the algebra is tediously messy and doesn't reveal anything and doesn't benefit the working memory. So the standard result is just to use the power law. So f of x equals x to the negative 1, so it becomes negative x to the minus 2. And the last one for this section, for f of x equals 7x, take 4, find the limit as h approaches 0 of f of x at h, take f of x over h. Same logic applies. F prime of x equals 7. Okay, section 3. Section 3. Differentiate y equals 4x cubed, take 6x squared, add 2x, take 9. So we can go term by term. So y prime equals 12x squared. Alright, 12x squared, take 12x plus 2. Y prime equals 12x squared, take 12x plus 2. So y prime equals 12x squared, take 12x plus 2 for y equals 4x cubed, take 6x squared plus 2x, take 9. Differentiate y equals 6 root x with a positive index for x. Y equals 6 root x is y equals 6 times x to the half. So y prime equals 3x to the negative half. Oh, I see. Positive index. Okay, so that would be 3 over x to the half. 3 over x to the half, or 3 over root x. So y prime equals 3 over root x when y equals 6 root x, and we have to differentiate it with a positive index of x. Differentiate y equals 5 over x squared. So y equals 5 times x to the negative 2. So y prime equals negative 10x to the negative 3. So y prime equals 10x to the negative 3 when y is equal to 5 over x squared. Oh, whoops. By first simplifying, differentiate y equals 2x squared add 1 all over x. So we can simplify this by splitting up the fraction into y equals 2x squared over x plus 1 over x. Then y equals 2x plus 1 over x. Then differentiating term by term, y prime equals 2 plus x to the minus 2. So y prime equals 2 plus x to the minus 2 when y equals 2x squared plus 1 all over x. Given f of x equals x to the 3 over 2, find f prime of 4. So f prime of x equals 3 over 2 times x to the half, and then f prime of 4 equals 3 over 2 times 4 to the half, which is 3 over 2 times 2, which is 3. So 3 is the value of f prime of 4 for f of x equals x to the 3 over 2. The next section is tangents and normals to a curve. Find the equation of the tangent to the curve y equals x squared at the point 3, 9. So y prime equals 2x, let x equals 3, then the gradient of the tangent is 2. The gradient of the tangent is 6. So we have m equals 6 and x1, y1 equals 3, 9. So we can just say 9 equals 6 times 3 plus c. So c is equal to negative 9. So the equation of the tangent is y equals 6x, take 9. So y equals 6x, take 9 is the tangent to the curve y equals x squared at the point 3, 9. Find the gradient of the normal to y equals x cubed at the point x equals 2. So y prime equals 3x squared, sub x equals 2. We get 12. And thus the gradient of the normal is negative a 12th. So minus 1/12 is the gradient of the normal to the curve y equals x cubed at the point x equals 2. Find the equation of the normal to the curve y equals x squared minus 4x at the point, oh goodness me, that's really hard. Find the equation of the normal to the curve y equals x squared minus 4x at the point 1, negative 3. Okay, y prime equals 2x minus 4. Let x equal 1. We get negative 2. So the gradient of the normal must be a half. And so y equals a half x plus c. So negative 3 equals a half plus c. So c is negative 3.5. So y equals a half x minus 3.5. So y equals a half x minus 3.5 is the equation of the normal to the curve y equals x squared minus 4x at the point 1, negative 3. Hello! The tangent to the curve y equals x squared minus 5x plus 6 at the point when x equals 1 crosses the y-intercept. Find the coordinates of that y-intercept. Alright, y prime equals 2x minus 5. Let x equal 1. Then the gradient of the tangent is negative 3. So y equals negative 3x plus c. Now, y equals negative 3x plus c, but we haven't actually found the point that we need yet. So I need to sub in 1 into the original function. Okay, and when I do that, I get 1, 2. So y equals negative 3x plus c, and we're going to use 1, 2. So 2 equals negative 3 plus c, so c is obviously 5. So the y-intercept is 5. So the y-intercept is 5 for the tangent to the curve y equals x squared minus 5x plus 6 at the point when x is equal to 1. Hello! How are you doing? Find the coordinates on the curve y equals x squared when the tangent to the curve is parallel to the line y equals 8x plus 1. Well, y prime equals 2x. We require 2x to equal 8 so that the tangent is parallel, and thus x is equal to 4. And so now substituting 4 into the function to get the y coordinate, we get 16. So 4, 16. So 4,16 is the point on the curve y equals x squared when the tangent of the curve is parallel to the line y equals 8x plus 1. Okay, so instead of doing more, we're going to give a break and go to piano. Yeah? All good. All right. Yeah, it's electric. Now, it's very important to stretch. So I'm going to do that, and I'll be doing some more mathematics. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow. Look, it's still extremely hot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6, 7, 8, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, let's go back to mathematics. Right, let me just get it set up. And here we go. Ready for round 2, if this thing can stop snapping. Alright. Okay. Oh, there it is. Okay. Okay. $38 times 42 is 1,596. 56 times 64 is 3,584. 73 times 87 is 6,351. 88 times 92 is 8,096. 118 times 122 is 14,396. 197 times 203 is 39,991. 43 squared, 1,849. 54 squared, 2,916. 67 squared, 4,489. 76 squared, 5,776. 88 squared, 7,744. 93 squared, 93 squared, 8,649. 112 squared, 12,544. 14% of 350. 49. 18% of 250. 45. 22% of 450. 99. Hello. 35% of 120. 42. 37.5% of 640. 240. 62.5% of 480. 300. 87.5% of 320. 280. 5/7 of 490. 350. 7/9 of 810. 630. 4/11 of 330. 120. 9/13 of 520. 360. 11 times 847. 9,314. No. 9,317. 101 times 406. 41,006. 1,001 times 508. 508,508. 99 times 67. 6,633. 999 times 48. 47,952. 25 times 348. 800. 8,700. 50 times 176. 8,800. 125 times 72. 900. 125 times 256. 32,000. 75 times 64. 4,800. 75 times 88. 6,600. 4,500 take 1,873. 2,627. 10,000 take 4,682. 5,318. 3,456 plus 2,987. 6,443. 8,750 plus 4,685. 6 divided. Oh no. Oh, it's going to start experiencing errors. I can feel it. Just keep going. 4,536 divided by 7. 648. 8,127 divided by 9. 903. 3,465 divided by 11. 315. 5,096 divided by 14. Oh, okay, so that's 364 or something like that. 6,750 divided by 15. 6,750 divided by 15. Is the same as 13,500 divided by 30, which is 1,350 divided by 3, which is 450. 4,096 divided by 16. 4,096 divided by 16. 256. 936 divided by 13. 72. 24 times 36. 864. 18 times 45. 810. 15 times 54, 810 as well. 35 times 28, 980. Okay, now we go back to chapter 12. Okay, now we have to do increasing and decreasing functions. Section 5. Find the set of values for which y equals x squared takes 6x is increasing. Now, it'll be increasing when the gradient of the tangent to the curve is positive. So, dy by dx equals 2x takes 6. And when is that positive? For what values of x is that positive? i.e., solve 2x takes 6 is greater than 0. Well, x has to be greater than 3. X has to be greater than 3. So when x is greater than 3, the function y equals x squared takes 6x is increasing. Find the set of values for which y equals x cubed take 12x is decreasing. Same logic, but this time we have to find out when the gradient of the tangent of the curve is negative. So if y equals x cubed take 12x, dy by dx equals 3x squared take 12. And when is 3x squared take 12 less than 0? When is 3x squared take 12 less than 0? Well, divide through by 3. So x squared take 4 is less than 0. That's what we're trying to solve now. Now, the roots of x squared take 4 are 2 and negative 2. So it's any value of x trapped between 2 and negative 2 to get when it's decreasing. So for x in the open interval negative 2 to 2, the function y equals x cubed minus 12x is decreasing. Hello. Whoops. State, with the value of the derivative in mind, whether or not the function f of x equals x cubed at 3x at 7 is increasing for all real values of x. So if f of x equals x cubed at 3x at 7, f prime of x equals 3x squared at 3. Now, 3x squared at 3 is always positive, and therefore the function is always increasing. So, yes, y equals x cubed at 3x at 7 is always increasing. Rather, f of x equals x cubed at 3x at 7. Find the set of values for which y equals 2x cubed, take 3x squared, take 12x is increasing. Okay, so we have to find the derivative function first, and then find out when it's greater than 0. Alright, so I think that the function itself is y equals 2x cubed, take 12x. Y equals 2x cubed, take 12x squared, take 6x. So dy by dx equals 6x squared. 6x squared, take 24x, take 6. And we can divide everything by 6. So x squared, take 4x, take 1. And then we need to find out when x squared, take 4x, take 1 is greater than 0. So I feel like I've made an error there. Yes, indeed. Okay, so it's actually good that I restart this. Okay. Find the set of values for which y equals 2x cubed. Take... It's really hard. Find the set of values for which y equals 2x cubed, take 3x squared, take 12x is increasing. Okay. dy by dx equals 6x squared. Take 6x. Take 12. Divide everything through by 6. So x squared take x, take 2. Find out when that's increasing. Alright, so by factoring, we get x take 2 times x add 1. And thus the roots are -1 and 2. And thus, it's increasing for x less than -1 and x greater than 2. So when x is less than -1 or x is greater than 2, the function y equals 2x cubed, take 3x squared, take 12 is increasing. Find the largest value of x for which the function f of x equals 12x take x cubed is increasing. So f prime of x equals 12 take 3x squared. 12 take 3x squared. And so we need to find the vertex of 12 take 3x squared. Alright, well that'll be the same as the function. I mean, it'll look the same as 4 take x squared, and thus 2 add x times 2 take x. And so the maximum value occurs when x is 0. When x is 0. Yes. Find d2y by dx squared for y equals x to the 4 take 3x squared. Okay, dy by dx equals 4x cubed take 6x, and so d2y by dx squared equals 12x squared take 6. So d2y by dx squared equals 12x squared take 6. When y equals x to the 4 take 3x squared. Hello, how you doing? Given f of x equals 2x cubed by x, find f prime prime of 1. So f prime is 6x squared add 5, and f prime prime is 30x. Sub in 1, we get 30. So 30 is the value of the second derivative at x equals 1 for the function Nope, I've forgotten. Okay, I've got to do it again. Gotta do it again until you get it right. Given f of x equals 2x cubed at 5x, find f double prime of 1. Okay, f prime of x equals 6x squared add 5. F double prime of x equals 12x. Let x equal 1, then it evaluates to 1. No, it evaluates to 12. Beg your pardon. So f double prime of 1 is 12 for the function f of x equals 2x cubed at 5x. Find d2y by dx squared of y equals 1 over x. If y equals 1 over x, then y equals x to the negative 1. dy by dx equals negative x to the negative 2. And d2y by dx squared equals 2x to the negative 3. So d2y by dx squared equals 2x to the negative 3, while y equals 1 over x. find d2y by dx squared when y equals x to the 1/2. dy by dx equals 1/2 of x to the -1/2. So d2y by dx squared equals 1/4 of x to the -3/2. Or 1/4 times the square root of x cubed. So 1/4 times the square root of x cubed is d2y by dx squared when y equals x to the 1/2. Hello. All right. Find the value of x for which the second derivative of y equals x cubed takes 6x squared, add 1 equals 0. Okay. Y prime equals 3x squared, take 12x. Y double prime equals 6x, take 12. And if 6x take 12 equals 0, then x is 2. So when x is 2, the second derivative is 0 of the function y equals x cubed, take 6x squared, add 1. Okay, section 7, stationary points and their classification. Okay, all right, do it. Find the coordinates of the stationary point of y equals x squared, take 8x, add 3. Okay, y prime equals 2x, take 8. And thus x equals 4. Right, okay, so nope, it's completely gone. Try again. Find the coordinates of the stationary point of y equals x squared, take 8x, add 3. Y prime equals 2x, take 8. So x equals 4. Sub in 4 into 2x squared, take 8x. Oh man. Alright, concentration is starting to slip a little bit. Hello. Find the coordinates of the stationary point of y equals x squared take 8x add 3. Y prime equals 2x take 8. So x is 4. Sub in 4. And you get negative 13. So 4 comma negative 13. Find the x coordinates of the stationary points hold on, let me just make sure that I'm not doing this completely wrong. Otherwise it's just completely pointless. No, that's right. That's right. Okay, that's fine. Find the x coordinates of the stationary points of y equals x cubed, take 8x. So y prime equals 3x squared, take 8. And 3x squared take is equal to 3x squared take 8. So x squared equals 8 over 3. So x would be square root of 8 over 3, so root 8 over root 3, so times the top on the bottom by root 3. Root 24 over 3. Root 24 over 3, so 2 root 3 over 3. I think it's 2 root 3 over 3 for the x coordinates of the stationary point of y equals x cubed, take 8x. Oh, no, that's completely wrong. Got to do that again. Find the x coordinates of the stationary point of y equals x cubed, take 3x. Y prime equals 3x squared, take 3. Set to 0 and solve. X is positive or negative 1. So x is positive or negative 1 for the stationary points of y equals x cubed, take 3x. For y equals x cubed, take 3x squared at 4. Use the second derivative to classify the stationary point at x equals 0. If y equals x cubed, take 3x squared at 4, then y prime equals 3x squared, take 6x. And y double prime equals 6x, take 6. And subbing in 0, we get negative 6. And because it's negative, It must be a maximum. So when x is 0, the curve y equals x cubed take 3x squared plus 4 as a maximum. Okay, so I'm officially low on mental batteries, so I think 100 minutes might be my current limit. But we'll see. Hopefully in the future, it'll be longer.